Hello everyone, my name is Rasim Kadir. I'm a second semester student in Electrical and Electronics Engineering at Bilkent University. In this video I will present my Physics 102 lab project. The purpose of this project to examine charge sharing process between two capacitors and to verify law of conservation of charge. Before moving to the procedure, let me explain the theory behind the experiment. As shown in the equations, since the circuit is closed, the initial charge must be equal to sum of the final charge. And by using the formula charge equals capacitance times voltage, and by rearranging these terms, I obtained the theoretical formula for V final, which depends on the initial voltage and the ratio of capacitance. Equipment I used a digital multimeter set to the DC voltage mode, a DC power supply, and various capacitors ranging from 10 microfarads to 1000 microfarads. Additionally, I used a 100 kilo ohm resistor. The function of this resistor is important because it provides a safe charging process. I started procedure by short-circuiting the capacitors to ensure they were completely discharged. This is a vital point because any initial charge on the capacitors would create errors in my data. Next, I connected the first capacitors in series with the resistor to the power supply. I allowed it to charge until it reached the source voltage. Once fully charged, I disconnected the power supply and I measured the potential difference across the C1. Then came to the redistribution part. I connected the charged capacitor in parallel to the uncharged capacitor. The charge flowed from the first one to the second one until the system reached an equilibrium voltage. I recorded this final shared voltage. I repeated this entire process with different capacitor pairs to ensure reliability. Finally, here are the results. In table 1, you can see the theoretical and experimental voltage values. The percentage error are consistently below the 5%. To analyze this graphically, I plotted the voltage ratio against the capacitance ratio. Theoretically, we expect a linear graph with a slope of 1. I obtained a graph as seen in the blue chart with approximately a slope of 1. Overall, despite minor errors mainly caused by manufacturing tolerances, the results successfully verified the total charge is conserved during redistribution. Thank you for watching.